we need to evaluate the integral x squared on the numerator, and then we have the square root of 5 minus x squared in the denominator, dx. Remember, we are looking for formula on the reference pages, so by formula, and go ahead and find the formula number. So leave it blank. Let's say we have what? What do we have that can fit this particular integral? $34. 34 is correct. 34 is correct, and 34 reads the following. The integral of u squared du over the square root of u of a squared. Is it a squared or? It's too small for me. Square a squared minus u squared. This thing equals to negative u over a times the square root of a squared minus u squared, but I think we have another term, plus a squared over 2, or the inverse sign of u over a plus the constant c. Okay? So match it to our case, the integral of x squared dx over a squared is 5. So a is the square root of 5. Okay. And I think we've done this before without using the table. You can tell where this thing coming from. Here we probably have a substitution, and here we have the inverse sign, of course, so we know how we arrive to this integral. So now we have negative x over 2 times the square root of 5 minus x squared plus 5 over 2, or 5/2, the inverse sign of x over the square root of 5. And this is the sticky point right there, to realize that even though 5 is not a perfect square, we look at it as equal is the square of another number. In this case, 5 is the square of the square root of 5. So this was a quick example.